So in this question, we have the absolute value of x plus 2, y is equal to 0, x equals to -3, x is 0, and we try to rotate with respect to x-axis. Very good. Let's visualize this. First of all, remember that if y is equal to absolute value of x in general, it's defined as if x is more than equal to 0, you get x back, and y, when x is less than 0, takes a negative sign in front of it. And in general, if you have u, which in this case is absolute value of x plus 1, again, if x plus 1 is more than equal to 0, you get x plus 1 back. But if x plus 1 is less than 0, you get minus x plus 1. So you have to have a negative sign in front of it. So how do we visualize this function? What the graph look like? Okay, let me just, I have x equal to -3. I'm looking at x values to make sure I have enough space. So this is my x, and this is my y. So when x is equal to -3, I get absolute value of, so when x is -3, I get absolute value of -3 plus 1, which is, I'm sorry, plus 2. I wrote down the final answer instead. -3 plus 2, which is absolute value of -1, which is 1. So when x is -3, my y value is 1, right? -3 and 1. When x is equal to -2, this becomes -2 plus 2, which is absolute value of 0 or 0. So you hit x-axis at -2. Then if x is equal to -1, you get absolute value of -1 plus 2, which is absolute value of 1 or 1. So here it goes up again. And when x is equal to 0, you're just point plotting and graphing this absolute value function, 0 plus 2, which is absolute value of 2 or 2. So this is the behavior of your absolute value function. Or if you remember the translation of graph, it is 2 units to the left-hand side. Perfect. So we graph this guy. X equals to -3 is your vertical line here. Y is equal to 0, you have your x-axis. X equal to 0, you have your y-axis. So what are we trying to rotate? We're trying to rotate these two triangular region about x-axis, right? So we get this object here. By the rotation, so let me make sure you see x-axis as well. And the rotation gives us this 3D object. And this is x equals to -3. This is x equals to -2. And this is just 0. Very good. So take a look. We can divide this up into 2 pieces. I'm going to erase unnecessary portion. This can be the integral between -3 to -2, then -2 to 0, because of the behavior of our graph due to absolute value, right? So here you have the volume, which is the integral of. So if you look at the cross section on this portion, you see the radius is located on the absolute value function. But the absolute value function here, for any x less than -1, you have to put a negative sign in front of it. So the area on the left-hand side is pi, and your r is equal to negative x plus 1 to the second power. For the area on the right-hand side, what do you have? You have pi times, and here if you look at the cross section here, it is located on this portion, which is increasing line x plus 1. You get x plus 1 to the second power. But remember that since we are raising these two to the second power, you basically can simplify this a little bit more. This negative, because of exponent 2, disappears. All right, very good. So what do we have? We can write this as the integral of negative 3 to negative 2 of pi x plus 1 to the second power, and this negative sign, because it raised to the second power, disappear, dx plus integral negative 2 to 0 of pi x plus 1 to the second power dx. So basically you can combine these two together. The volume is negative 3 to 0 of pi x plus 1 to the second dx. For this, you can use u sub, or you can basically just calculate the integral by writing it in expanded form. Either is fine. Okay. So v is equal to pi a third x plus 1 to the third negative 3 to 0. So the volume is pi a third. So if you plug in 0, you get 1, minus if you plug in negative 3, you get negative 3 plus 1 to the second. So the volume is pi thirds times 1 minus, here we have, let's see, let me make sure I have calculate everything correctly for you. I forgot exponent 3. Yep, here we go. Let me fix that. This has power exponent 3. Okay, so when you plug in 0, you get 1 back. When you plug in negative 3, you get negative 2 to power 3 back, which gives you pi over 3 times 1 plus 8, or 9 pi over 3, or 3 pi. That's how we calculate this volume. Make it a little bit smaller so you can see everything.